Hey, good afternoon, Dr. Ford and my teammate Michelle. My name is Desing and today is 4th of May 2025. I will be presenting about the part B for Lab 1. So this part is about addition and subtraction of variable. So we have four variables here, variable 1, 2, 3 and final variable. Each variable 1, 2 and 3 holding different value is shown here. So the first step we need to do is adding the red button like this by pressing the bar beside the number. So, and start the debugging. Step over. So now the terminal we haven't got any value yet because we haven't proceed with the code. We haven't run the code below. So after running the code, we will see the difference. Minimize it. So this line move EAX value 1 means we are moving value 1 to the register EAX. So value 1 holding the value of 10k hexadecimal. So we can step over and see what happened next. So now EAX holding in the initial value of the register and value 1 holding a value of 10k hexadecimal. So continue to step sorry, we can watch the item here, value 1. Okay, debug, step over. So now after proceed a step over from this code, we can see that EAX changes its value to 10k hexadecimal, which is the value of value 1. So moving on to the next line, add EAX value 2 means adding value 2 to the register EAX. So currently the register EAX holding the value of 10k. After adding value 2, which is 40k, I believe that the EAX will change its value to 50k. Next, step over. Yeah, 50k over here. So off to mention that we can also see the memory address of the variable by typing this. Yeah, so this is the memory memory address for value 1. Then value 2 we can also watch for its value. Then value 3 and also final value. Final value. Final value still empty because we haven't do anything with the final value yet. So we continue to step over. So we step over from this line which subtracted value 3 from EAX. So value 3 holding the value of 20k. So just now the EAX is 50k. After subtracting 20k, it becomes 30k. So lastly, we need to move the EAX value to the final value. So we can see the final value here, the memory address of the final value. So we can see it is empty, nothing here. So let's step over this line and look over here. The value of final value has changed to 3. Yeah, here also. What's that? I don't know. Okay, then we need to call our dump register to display the register. Okay. Before exit the code, let us look at the disassembly code. So here is the disassembly code. Here's the value 1, value 2, and value 3, final value. Yeah. Then minimize. Okay. now you can see that the terminal here has updated the EAX value to 30K. Okay, so let us exit the code. Continue, exit. So here's the result of this assembly code, and I'm gonna screenshot it and put to our lab manual. Alright, so that's all from me. Thank you.
Good day, doctor. My name is Michelle, and today I'll be explaining part 1C for our first lab. So here at the comment part, I have written my name, Michelle Ho Jasin, and also my teammate's name, Tay Sining. And then the today's date, and then the revision part, I leave it blank. Okay, so before I start the debugging process, I'll explain briefly about this part of code. This part, I will explain it line by line when I do the debugging process afterwards. So here we have to include the library, and then as for the data here, we have val word1, val word1, val word2, val word3. So the data type is word. So here we initialize the val w1 with 1000 hexadecimal, val word2 4000 hexadecimal, and val word3 2000 hexadecimal. And same thing goes to here, val b1, val b2, val b3. We initialized it with 10 hexadecimal, 40 hexadecimal, and 20 hexadecimal respectively. And then the data type for these variables is data type byte. And here you can see final val w word, final value b byte. We have put question mark here, which means we are not initializing it with a value, so we are putting a question mark. So we'll find out the value of this and this during the process of our debugging. Alright, so to start debugging, we have to do this and build the boot, and we start debug. We're going to use this one, step over, with the shortcut F10. So we click it. Okay, and yeah, so we'll be going through the debugging process by also looking at this five things, which is first one is watch, second one auto, third one memory, fourth one register, and the last one disassembly. So the disassembly, I will explain it like after I go through this one, and this four I'll explain it like step by step with the line of codes. Okay, so here I'm going to add stuff to my watch. I'm going to put these 8 things here so that we can see the value, the changes of value during the process. Val word2, val word3, and also final value word. Okay, and the bottom part, val b1, val b2, val b3, and also final value b. Yep, so this 8, we're gonna write it here first. And for the auto, now it's empty because later during the debugging process, it will like come out values here. As for the memory one, I haven't finished explaining this one. So you can see we move back to the watch part. So you can see this one, val w1, the value here is 1000, and then it is set to hexadecimal display. So this one 1000, why? Because we have initialized it with 1000 hexadecimal, and 4000, 2000, 4000, 2000, it's correct. And then here you can see the final val w, it's 0000 because we haven't initialized it. We didn't initialize it with anything, so it's value 0. And the same thing goes to here, val b1, b2, b3, 10, 40, 20, 10, 40, 20, as you can see here. And then question mark, also 00. Okay, so here for the memory part, let me show you this memory, this val word 1 first. So I'm going to enter the address of it, val word 1. Okay, so you can see it here. We are going to see this two column only for the word part, this two column only. And then you can see here is 1000, but here is 0010, because we are going according to the little ending rule, so we are going to read it from the back. So it's actually 1000. Let me minimize it to make it clearer. Can I? Yeah. So we are going to see, read it from the second one, 1000. So same thing goes to the other one, val word 2. We have val word 2. So it's 0040. So it's actually read as 4000 as shown here. So it's the same. So same thing goes to this, and let me show you this one. Val B1. Okay, so you can, for this one, because it is byte, so it will be only be using 2 digits. So it's 10 as shown here, 10. And if we put second one, val B2, so we are going to read the first one only, 40 and 20. So this one here, okay, let me put this first. Forward one. So this one here these two digit at the back is the AH, is the high bits, and then at the front here is the low bits. So yes, so that's for the initial explanation. So I'm going to set the address to final value word. So here later we can see the changes in value. So okay, after explaining memory, here we have register. So the register we're only going to be using EAX, because AX here and AH here. So AH is the high bit part of the AX register. So we're going to only be seeing observing these 4 digits at the back. So all this we can like ignore, because we're not using those register. Okay, so now that I've done explaining, so I will start to run the debug by pressing F10. Okay, so I've pressed F10. So what it did is it's going, okay, later I press F10 once again, it will run this line 22. So let's run it. Okay, line 22. So you can see here's the change. The value of AX here, it became 1000. Of the AX register became 1000. Because why? Because here we have run this line 22. We have moved the value of val word 1 with 1000 as initialization. We moved this 1000 into this AX. So now the AX register we have 1000, which you can see here, and also you can see it here. Yes. Alright, so let's press F10 again. So just now we've pressed F10, and then it has run this line 23. Add 4000 hexadecimal from val word 2 to AX. So initially we have AX as 1000 hexadecimal, and then we add 4000, so it will become 5000. So here we can see at the auto it's 5000, correct, and then here at register 5000, correct. Okay, and for the register, for the memory part, because we're observing this one, and yeah, we're observing this value, and then we are observing this one final val W, and then we haven't reached here yet. We are just at here, this 2 line, so it will not like show any changes. Okay, so let's run F10 one more time, and it should do this subtracting. Okay, F10. Okay, so you can see just now the value of AX has it is initially 5000 and it became 3000. Because why? Because here val W3, the stored value, the initialized value is 2000, and then we subtract 2000 from AX. 5000 subtract 2000 we'll get 3000. So this is the AX register AX, so we can see it here at the last 4 digit of this register, of this And then when I run F10 again, it will do this. Move the final value, which is 3000 here, yeah, this one, 3000, into the final val w. So the final val w here will become, the value will become 3000 from 0000 from to 3000. So let's run F10. And yeah, you can see it here at the memory. So this one is the address, this two address of final val w. So this one is read as 3000, yeah, 3000 hexadecimal. So the value has been stored into final val w. And the next one we're going to do call dumb register. So we press F10 and it will be shown here. Let me minimize it a bit. Yeah, it will be shown here. So we are looking at this one, EAX, because this one is the register we use. So EAX 3000, here 3000, yeah, it matched. So like this one is the, how to say, the final value of the register as for now. Okay, and then we're going to do line 28 to 32. So here we are not going to observe final val w anymore, so we are going to change the value to the address to final val b, is it? Yeah, final val b. So we're going to see what will be the changes in value in this column. Okay, so let's run yeah, this one AH. So let's run F10. Okay, so just now we have run line 28, and then the value of AH has become, just now we can see, just now I forgot to explain, it was 0, I think, and then now it became 10 because we have added the 10 hexadecimal from val B1 into the AH register, so it become 10. And yeah, at the address here you still can't see anything because we haven't reached final val B. And here we can see the register has become 10 1000, and then the changes are met at these 2 digits because we are doing AH. So AH is the high bits of of a register, so it will be this one. This 2 is AH, 10 is AH, and then 00 is AL. We're not going to use AL for today, so AH here changes it here. And then let's press F10 again, add AH, add 40 to AH. So 10 plus 40 we have 50. So you can see here it's 50. So the value have changed, and you can see it also in the register. So it became 50. And then we run F10 again. F10 just now we've run the line 30. So it subtract 20 from AH. So 50 minus 30 will have 50 minus 20 will have 30, sorry. Okay, so the value of AH now is 30, so we can see it here in the register also 30. So yeah, it matches. And then line 31, later when I run, it will move the 30 hexadecimal into the final val B. So let's run F10. Yes, so you can see it here after we run the value, you can see at the memory page here. Here the AH part, yeah, the AH part has become 30. We can see it here. Here got changes of the final val B, and also changes, oh, no changes here, sorry. Here we can see the final val B value have changed after we run this line. And then we can see here final val B become 30. So the value is stored into watch 1. Just now I forgot to mention, here final val W also change. After we run this line also change. Okay, so I'm going to press F10 again, so it will call dumb register. So it has called dumb register. So you can see the second column here, bottom one, these 3 lines, we're going to see this one. So 30 is the final value of the register. It matches here 30 because 10 plus 40 minus 20 equals to 30. So this is the dumb register part. Okay, and then after that, before we exit, I'm going to show you the disassembly. The disassembly here, it shows you like the full process of what we did just now. So starting from here, we have move AX val word 1 start 1000 hexadecimal. So it's basically moving 1000 hexadecimal into this. And then add AX at 4000 hexadecimal. So 1000 at 4000 become 5000, and then subtract 2000, the AX finally become 3000. And then move the 3000 into this, so it store the result 3000 hexadecimal into here, and call dump register, which is the compile page I've shown just now. And yeah, move, and then this one is for the first part. And for the AH part, we have value B1 is initialized with 10 hexadecimal, and it is moved to AH, so AH become 10, and at 40 AH become 50 minus 20 AH become 30. So the final value stored in here should be 30, which is also correct because yeah, 30 here as shown. And call dump register, and then okay, so this is for the disassembly part, and then I'm going to exit by pressing F10 again. F10. So I've exited, and then this one, press any key to continue. Okay, so this one is basically the full procedure for lab part 1C. Thank you for listening.